Hello, my name is Brendan Tierney and thank you for joining me today with this video to talk about Oracle or Enterprise or running or in the database to do some data mining, advanced analytics um, on your data. I'm sorry I can't be with you today, but I've already committed to being at the Oracle user group in Norway. So at the moment I'm on a boat that's going between Oslo and Kiel in Germany. Um, so hopefully the seas aren't too rough. Some background to myself. I've been kind of working in the Oracle world for a number of years now, kind of over 22 years now. I have a website and kind of base a lot of my publications and blogging and articles on, which is called Oralytics. So if you kind of do a search for Brendan Tierney data mining, you'll come across it, or oralytics.com as well. I'm the editor of the Oracle Scene magazine, so hopefully you'll get a regular copy of that. I'm based in Dublin, where I kind of do most of my work working from home in my home office. Last August, I published a book with Oracle Press. I'm McGraw Hill on using the Oracle Data Mining tool and the Oracle Data Miner option within the database. So it's the title of the book is Predictive Analytics using Oracle Data Miner. So what am I going to cover today? I'm going to kind of give a quick introduction to OR, have a look at the advanced analytics option, what does it consist of, look at the various different OR technologies, the OR language technology that Oracle provides, and then we'll get into looking at some examples of ORE, running it within the database, running OR using SQL, and how you can include in other products. There is a lot of OR code and SQL code involved in these demos, so it's not just talking about the technology and what it can do for you, but it's actually showing you how you can actually perform some of the various different tasks on it. So let's start with having a look at OR. So the OR language has been around for, well, 22 years. So it originally started off being called the statistical language, and it was kind of built as an alternative to like SPSS, SAS, and other kind of products that are around at the time, like really expensive products. So through various different kind of iterations and improvement, it kind of evolved into kind of the OR language around 96. It is kind of an open source, free language tool that is being kind of built upon and constantly enhanced by the user community around the world. There's millions of users available, and you can go to the kind of the Orcran web page where you can download the latest version of it. There is loads and loads of packages available in it, and we can see here on the slide is that over the last kind of few years, the number of packages has increased dramatically. Like as of a few days ago, there was over 6,300 different packages. So whatever kind of statistical language or statistical methods, graphing methods, machine learning methods, anything like that you want to perform, you're going to find some packages or somebody has written the code to allow you to do it without you having to go and write everything from scratch. One of the real benefits I think, and what I really like about OR is all the graphing methods that are available. You think about the different graphical methods that are available in our different tools, is in a way they are quite limited. Or whatever you think of, like it's like every other statistical method, it is available in OR. So one of the examples I'll show you later on is how we can actually go about including some of these OR graphs into our dashboards, into our OBI or any other products. One of the most common kind of tools to use to access OR is OR Studio, which it's a nice little development environment that we can use to write our code, test our code, see the results on it, produce the graphs, all in one nice clean environment. And this is the tool that I'll be using later on to show you a demo. But it's widely used by most users. To access the data in the database using OR, traditionally you would be using something like or JDBC or ODBC in order to connect to the database and being able to process all the data that way. It pulls the data down onto your client machine and allows us to do lots of statistics, lots of analysis on it, lots of graphs, and being able to kind of start getting lots of insights into our data. As an extension to that, Oracle also provides a library which allows us to access the database in a more kind of efficient manner than using, say, the OR the or JDBC and the or ODBC connection, and it's built on the Oracle client software. So we this is what like for using SQL Plus. Or any the kind of the other tools being able to access the Oracle database, it's tuned to process data in a sufficient manner as possible. So it kind of piggies back on all of that, and kind of some tests have shown that the Oracle package can give up to 70 times quicker access to the data than using some of the other methods. Now, it's not available on all platforms, even though it is a package within Oracle hasn't made it available on all platforms. So you need to check uh, what operating system you're using and whether it's available on that. Or is brilliant, but it does have its limitations. Okay, so some of the limitations to do with or traditionally is to do with kind of scalability, performance, and product deployment or production deployment. So with scalability, we are kind of limited with the number of CPUs that we can use. Traditionally, like or is kind of constrained to using one CPU. We're also constrained to amount of memory. So typically, the amount of memory that we have available on our laptops or our desktops, because the data is pulled down onto those. And so we are constrained with it. It's like, if you try to open up a large file in Excel, we eventually run out of memory. It's the same kind of idea. So as you kind of scale into more kind of production environments, into more kind of larger scale volumes of data, is that, or begins to struggle. Yes, we can get into doing lots of data sampling in order to reduce down the data, but we are still going to struggle with processing all our different data. One of the main challenges, though, is with the deployment of solution. So if we produce like a churn prediction system or is that, well, in order to embed it within our applications and make it more real time, is that, well, typically we'll need to recode what we've done in or into our Java or C++, C Sharp or SQL or some of or whatever other language that we're using. So it has kind of limitations that way. And this is one of the things that Oracle has done, and now we're seeing like Microsoft doing now, is being able to kind of take the OR code and embed it within as being a core feature of the database, so that we can actually take a lot of these or scripts and lots of advanced analytics that have been done using or, and we can just run them in the database with the minimum of coding. There is some recoding needed. It'd be nice if we were able to translate it fully without changes, but some minor tweaks in order to ensure that we are connecting to the database. So Oracle or Enterprise comes as part of the Advanced Analytics option. The Advanced Analytics option, traditionally up to a couple of years ago, before we had Oracle or Enterprise, consisted of the Oracle data mining option within the database. So within the 12c database, we have over 15 different algorithms that are available that can cover probably 90-95% of all advanced analytics that you want to be doing. And there's a few ways we can go and access that. We can go access it through like the SQL Developer tool using the workflow based environment where we have to kind of minimum coding, so it's really good for analysts to go in and do it. And this is very similar to like SPSS and SAS Enterprise Miner, which we get now, where we can also do it using SQL and PLSQL, because behind the Oracle Data Miner GUI tool is basically calling lots of SQL and PL SQL packages, so like the DBMS data mining package and all the different data mining functions. A new feature, just want to highlight it to you, in 12c is this predictive query. So if you're not interested in trying to tune your algorithms or find the best variables on else, and you say, I just want Oracle to tell me what the answer is. So if you kind of trust Oracle to do it, we can write a query like based on using analytical functions that can go off and make predictions. So it'll identify the algorithms, it'll do all the tuning, it'll identify the data, it'll work out what it needs to do data, and then it'll come back and make the predictions for you. So it'd be worth checking that out. One last thing though, before we move on, is that the database and all versions of the database come with over 280 different statistical functions within the database, and these come as standard in all versions of the database. So when we talk about we want to do lots of statistical analysis on our data, is usually the last thing you think of is SQL. Well, we have loads of functions that are available in the database, and these are designed to scale across multiple CPUs, multiple millions of records across whatever memory that we have. So like they're designed to work really quickly. I'll come back to this list in a few moments. So a couple of years ago, we got Oracle R Enterprise. So with Oracle R Enterprise, is basically we're taking the R language and being able to say, can we embed it within the database, being a core feature of the database, being a core kind of option within the database, so that I can come along and take my R scripts, and when I run them, is that it's actually being run on the server, not necessarily on my client machine. And then can I embed it within, say, procedures and functions within the database, and can we actually integrate it with the graphics that are the graphing capabilities of OR into our various different applications. So what OR technologies are available? Well, I've already mentioned about Oracle, which is kind of a free package that they make available, but there's also Oracle provides a an OR distribution. So this is where they've kind of taken a version of OR, one of the most current versions of OR, and they'll actually have certain packages and functions and procedures within those that are kind of tuned specifically to work with with the Oracle database, to work with certain kind of volumes of data, being able to work and integrate with, say, the big data appliance and various other kind of environments. And again, that's kind of a free download that Oracle kind of gives back to the community. Building on top of those two particular products, if you want to call it that, we have Oracle or Enterprise. So this is where we kind of being able to say we can take that or distribution that Oracle has, and we can embed it to being a core function of the database. So it is integrated in with the database. Additionally, it also provides a number of interfaces and other kind of like packages like our Oracle, so that we can actually connect to our Hadoop environments and being able to run the queries against the Hadoop, our data on Hadoop, being able to analyze and being able to pull the necessary results back. And again, if we're using some of the Oracle hardware, is that it pushes down some of those analytics down onto the hardware and utilizes a lot of the benefits from there. So with Oracle or Enterprise is, like I've said already, it's a core part of the database. It's become like another language that we have that we can run on the data in our database. Right? So just full integration into the database engine. We can run or not just on our client, send them or code to the database being run there and sent back, but we can also run or from within the database. Okay, we can create our objects, so create models and different kind of data types and structures within it, and we can then embed all of those and include all of those within our SQL and PLSQL, and hence once it's in, we can call it an SQL and PLSQL, then we can embed it in any of our Oracle products or anything else that we may have that runs SQL. One of the real benefits is that, well, we can integrate all the new kind of bells and whistles that come available within OR. So if a new package comes up that has a particular feature that does exactly what you want to do, or is a lot more efficient than anything that has been available before, we can easily integrate it into our database. We don't have to wait for a new version of the database to become available, which is like every couple of years, 18 months, couple of years, we can make it available today, in an hour, in a few minutes, because all we need to do is just install that new package within the database. In order to do this, well, you do need certain versions of the database. So at a minimum, you need the 11.2G database, which is coming under kind of some support issues at the moment. But if you are kind of running it, you do need to have particular patch installs of it, so you just need to watch out for that. And then within the 12C under the container pluggable configuration, you do need a particular version of our Oracle or Enterprise installed to be able to run it. The thing is with using Oracle or Enterprise, it's always going to be kind of a point or a couple of point difference away from the current release of OR. And the reason for that as well, they need to do certain customizations and efficiency issues on it. So if there is a particular package that you want to use, you need to be careful of it, make sure that it is supported under the particular version of OR that is being used as part of Oracle or Enterprise. With Oracle or Enterprise, there's this idea of a transparency layer. So with the transparency layers, the idea is that we can take a lot of our code We can say, and we can point it to the database, and the minimum of coding changes needs to happen. So yes, we do need to change things about how we connect to the database and maybe manage certain aspects of that, but all the kind of statistical analysis and coding that needs to be done on the data doesn't need to be changed. And part of the reason for that is that when we run our scripts, that the transparency layer will look at our commands are being executed and looks to translate where it can those OR commands into SQL in the database. Because once they're translated into OR or into SQL, then it utilizes all the performance features within the database. And I'll come back to that. So give you a quick example of taking a bit of OR code. So if we have a bit of OR code here that kind of we want to do some aggregation based on some data that we've defined, right? So this is a pointer to an object in the database, and we want to do some aggregation based on looking at some data based on an affinity card, and do aggregation based on age. So when we take that piece of OR code, is well, we send it from our client to our database. Right, and once the database gets that, it'll look through through the transparency layer, seeing can we actually map that into a piece of internal code that we can execute in a more efficient manner. And when it converts it into the internal code, it converts it into a bit of SQL, gets the results and sends it back to the client, which then can tell us different things about how many records we have, how many attributes are involved in the results, and then we can look at a subset or an initial kind of set of six records from the data. So it becomes a bit of a cycle. So this SQL code, the results are then translated back into OR format, sent back to the client, and we can then review the results. One of the things when you're looking at Oracle or Enterprise talk about, well, it comes with all of these statistical functions. So you might remember a few slides ago is that here's the statistical functions that come in the database is effectively the same list that you'll see advertised with Oracle or Enterprise. And even when you're looking at the new Big Data SQL, is the same setup. SQL functions get translated within the database. Also within the database within Oracle or Enterprise, if you want to do things like k-means clustering, node clustering, naive Bayes, decision tree, association rules, and so on, is that, well, we can utilize the in-database features in there, and when we kind of maybe run certain data mining models, it'll automatically translate them into the in-database functions. So those SQL and PL/SQL functions within the database to translate it. But it does give us some extra data mining models and algorithms that we can actually use, along with everything else that comes within the OR suite of packages. So with the transparency layer, there's a few other things to keep in mind. It just doesn't convert them into SQL. All right, is that when you issue commands in OR to use an Oracle or Enterprise, it doesn't execute them one command at a time. What it tries to do, it kind of stacks up the different commands, it packs them up and looks at, well, when I need to display data within my Oracle or Enterprise environment, is it only then goes and executes the code. Because what I look at is by stacking up with the different commands, I look at, well, is there ways I can optimize and reorganize these commands? Is there ways I can do performance optimization on the data? What parts of it can I translate into the SQL and PL SQL functions within the database, and what bits need to be run as actual OR commands in the database? So it looks at optimizing all of those so that we can get the results coming back from our data in as an efficient manner as possible. Again, you're going to be running this against reasonable volumes of data, so it is important to be able to do some optimization on the data. So let's now switch over to having a look at some examples of using Oracle or Enterprise. I'm going to switch over into my OR Studio software, which will kind of go through a whole series of different commands. So there is lots of code, so hopefully you'll be able to follow it. But if not, over the remaining kind of slides, what I have here is an examples of all the code that I'm going to run. So you can actually take this code and take all of these commands, and if you have the sample data set up within your database, then you can effectively come along and replicate everything that I'm going to show you. Okay, so now I'm going to switch over. So here we are in OR Studio, which is the tool I'm going to be using to demo Oracle or Enterprise. So this is the typical kind of tool that most data scientists, predictive modelers, stats guys would be using in order to be able to use OR. So before we can actually get using Oracle or Enterprise, we need to load the required libraries for it. So this is where our ORE and the packages and the necessary libraries have been installed for it. So the first thing that we need to do is to connect to the database. Now there's a couple of things to watch out for here on the connections of the database. So we can see down here in the bottom console the results from it. So once we connect to it, we get our results coming out of it. So we can do various things like checking to see, well, are we connected? And also what objects that we have. Now, what I have listed here in this schema is some of the sample data sets that would typically come with the advanced analytics setup. Now, as your analytics environment grows, you're going to be creating lots of different tables and views and objects within your database in order to create different subsets and test out different scenarios and to build your models and test out your models. So sometimes what you need to do is, or you don't want to do, is you don't want the syncing between all the objects in your database or in your schema coming down into your Oracle or environment. So so one of the things what we might want to do is we want to be able to limit it. So what I'm going to do is I'm going to disconnect from it. And this time in the connection is we have slightly different connection details. So in this particular case, we're saying all equal to false. So which basically says I just want to establish a connection, but I don't want to sync up any of the metadata of any of the objects that I have in my schema. So when I do that connection and we list out the objects, this time we don't get anything appearing in our connection list because we told it not to bring down anything. So once we've done that, all right, what we can do then is we can tell our environment is, well, what objects do I want to use? So here I have an example of, here's just 3 tables that are in my schema that I just want to work with. Right, so when I kind of sync up with those and do the listing, now we can see that these objects are now available in my schema. Well, it's the metadata is available in my OR session, which refers back to these objects in the database. So this can save an awful lot of time when you're kind of setting up your connections and disconnecting and things like that. So we can use that to reduce kind of the search space that's available to us. We can also do a kind of attach different objects to our schemas, and we can also test to see if objects exist, right? And sometimes that exists within our schema, not necessarily within the listing that we can have. And we can also kind of have multiple schemas as part of our metadata. So we can say, well, for the DM user schema is what objects do we have listed in our environment. So once we've established the connection, we've set up the tables and views and objects that we want to be able to access either in one schema or in multiple schemas, then we can actually start performing some tasks on our data. So the first thing I'm going to do is I'm going to take some data. I want to check to see, well, does a certain table exist in our schema? So there's a table that I want to be able to use that has some data I want to be able to analyze. So it doesn't exist. So our first job that we need to be able to do is to, well, I'm just going to drop it. I want to be able to load it in. So I want to load in some data from a table or from an external file. So here we're using just standard OR code to be able to read in a text file, a tab delimited file, and we can actually see that some of the properties of it is like just over 1,300 records in it by 5 attributes, and probably class of the object is a really important thing because this helps us determine what is an OR object on my laptop, on my PC versus an OR object that points to something in the database. So in this particular case, we see that it's there as a data frame. So this is something that's local to my laptop. Now I can take that particular object and just push it out to the database. Simple as that. And it's done. All the data is pushed straight across. And you saw how quickly that actually happened. If I was have to use the OR JDBC connection, whatever, it would still be running at this point. It's a considerably slower. Now we've created that object in our schema, but what we need to do if we want to be able to use it, we need to just get the metadata of it. So we pull down the metadata of it, and if we check the class on it, now we see something that's a bit different. So down here at the bottom, we get to see that it's an ORE frame, an ORE base object. So this tells us that that variable that we have now, the T data, now points to an object in my Oracle database. Okay, so we can go and query it. So we can go and get some, this is like doing a select star from the table where row num is less than or equal to 6. And we can verify, yes, this is the table. And if we were monitoring, have monitoring set up on our database, we'd be able to go and see that, yeah, that was the type of command that was actually run against the database. So now let us use some of this data to perform some analysis on it, all right, or similarly. So here's another bit of data that we have, which is mining data build view. So we're going to kind of get the metadata for that. We can check the object that exists in it, and we can start, writing our queries effectively. We can start exploring the data, but we're all going to be using OR commands on it. The summary is a really good one because it goes off and kind of builds up an idea of the typical kind of values that we have in our data, right? So as you can see, from starting the command, it takes a few seconds to come back because part of what it's doing, even though it's only on 1300 records, it's going off and effectively writing lots of SQL behind it to gather that data. Now that we have that data, right, or we can access that data, we can start doing some of the charting of it. So this is where we're using the data that's in a table in the database, and we can start using some of the charting capabilities of OR in order to be able to produce some useful graphs, useful insights into it, and we can start creating lots of different varieties of charts and histograms and other kind of graphing techniques on our data. All right? Remember, the data is in my database. What it's sending back is summary aggregated data back to the OR environment, and then using that data to create those charts. So we're having the minimum of data movement being performed in each of these particular cases. We can also take subsets of the data. So I just need to drop the object that already exists in the database. Right? We can check to see what is the data type of it. It is an ORE frame, so it's pointing to that object in the database. And we can, again, get our dimensional information. We can get the attributes, so do a describe of it. All right. And now what we want to be able to do is we want to create a subset of the data. So this is sometimes, if we want to kind of work with subsets because, maybe working with the entire data set is just too big, or maybe because of the subset, and we would have seen it from one of our previous graphs, right? That, well, over here is, well, one of the countries consists of pretty much the majority of our data, something like it's 90% or 93% of our entire data. So if we want to say create some data mining models, we want to maybe focus in on that particular country first. So the first thing we need to do is we need to create that subset. So extract that subset from our entire data set. So in a way, what has been defined within the database, within our OR environment, our repository within the database, is like a view, a database view that looks at that data and applies that basically where statement of where country name is equal to United States of America. When we look at that particular object, again, we see that it's an ORE frame. It is an object that's stored within the database, right? Or is temporarily stored within the database. And we can perform our normal actions on that particular case. We can see the number of records that are being produced, right? And we can take that and we can kind of push that out to our schema, and it's kind of saved as a temporary object within my schema. But when I go and look at it, is, well, we can get to see that the object doesn't actually exist in our usual table listing, right? Because it's a temporary one, right? It's a temporary structure, temporary object that's created in order to do it. So now what we want to do is say, let's create a table for that, right? We take that, push it out. And we saw that that was actually really, really quick, right? Because it's effectively the object is already in the database. We just do the commit on it, and it becomes part of our typical environment. If we do the sync on it now, we get to see that that object is now there as part of our schema, and it's part of our listing. So any objects that we create as part of our work and our session also gets synced with the metadata that we have. So some examples of using kind of the transparency layer, so which is we've already been using, is if we take the example that I showed you on the slides a few minutes ago, is how, like, can we actually perform a query on that table, doing some aggregation on it, which goes off, executes the data, does the group by, does the aggregation, the count by, and it displays the results, and we can plot that against our data. And again, we can go off and do summative information on it in order to get some of the typical values that we would have coming out of it. Now, so that's kind of the basics, kind of typical data analytics that you might get into, some of the data analysis you want to get into, and some of the graphing. We can do a lot more on it. In the next step, what I want to do is I want to show you how we can create some data mining models. So our first step is we want to get the data that we want to be able to use to create our models. And this time what we're going to do is we're going to create a data mining model using the in-database data mining functions. So in this particular case, we want to be able to create an ODM, Oracle Data Mining, decision tree. All we need to do is pass in what is the target variable and what is the data that we want to be able to use. Simple as that, right? And that will go off and generate, producing all the SQL and PL SQL necessary to generate a decision tree model, to test it, to evaluate it, and being able to kind of come up with the appropriate settings. And it's all done really quick. Right? And then we can start looking at some of the various different properties on it. We can see lots of different things to do with, say, the model name. Right? So in this particular case, we get to see that the model name is ORE and some sort of number. So this is kind of like an object that's created within the ORE environment. So if we switch over to SQL Plus, and if we just run a little script here, is, well, we can go and see, well, here's the object that exists within our data mining models. Okay, so it's there in our database. We can see that it's there in our database. We can also get to look at some of the settings on it. Again, this is writing some SQL behind the scenes, getting the results, retrieving it. We can see what attributes were involved in creating that data mining model, and then we can get to see lots of, if you wanted to create a decision tree, what are the different nodes and branches that are associated with that. And then we can find out what was the kind of the parameter settings that were set up in order to particularly call it and use that particular data. Once we've generated the model, one of the things we typically want to do is we want to be able to apply it to our data sets and being able to look at like a confusion matrix, which just gives us an idea of, well, if we were deployed on a test data set, how many did we get right, how many did we get wrong, and we can use this in order to determine, if we're creating multiple different data mining models, which ones are, or which model actually performs best for our particular set of data. Now, if we want to say we want to persist this in a more kind of realistic way, so we want to create something that's a bit more meaningful, we can take that mining model, and one option is that, well, we could store it as a object within the OR repository in the database. So it stores as an OR object in the database, so which allows us to retrieve it and let it just the OR environment communicate. And then if we actually had that actually stored and we wanted to use it at a later stage, we could just load that back into memory. So what that effectively done is taken that data mining model, stored it in the database, and we've now pulled that data back from our model and brought it into our environment, which we can now take to go along and say, and apply it to our new data. So we have a new data set. So mining data apply is that we can take that particular data set and we can get the metadata of it. We can check the object of it. It's an ORE frame. It's in the database. And what we can do is, again, we can get some the basic information of it. And we can apply that model to it. Right? That 1500 records. That applying of the model just happens in a fraction of a second. So we can now look at the results of it. So the results of it will come along and say, like, for the first record, the identifier, here's the predicted value, here's the prediction probabilities, which are really useful for refining our data sets. So that's our data scored. Right? We can look to see, well, what size does that data set consist of? We can verify the results. So in this particular case, we can see that, well, the apply data set consisted of 18 attributes and the output consisted of 18. So what we want to be able to do is we want to join up the results with the original data set. Now that we get them to being 21 attributes, and we can move on from there, and we can say, well, we want to take that particular table and we want to take those results and store those results within the database. So everything is there, all stored, all ready to use. Now, one of the things that we may also want to do is we may want to take that particular data mining model. It's not necessarily a very meaningful name, and what we want to be able to do is we want to make it a little bit more meaningful, particularly if you're in a production environment, is that you don't have to change your code every time you update your data mining model. What we want to do is rename our new model into the production model name. So we can take this, which is, as you can see, is taking a bit of ORE and calling a bit of PL SQL that will go off and create that model or rename that model within the database. So if we switch back over to SQL, we can go along and do it. Now we can see that, well, the only models that we have available that were created today is our demo or the decision tree model. So this has been renamed. This one that we had earlier has been renamed to the production environment, so our production code can now start to call all of that. Right, and giving an example of being able to call it is we can now say write some SQL that will call the prediction functions and apply that model to it. Okay, and we get our results back in real time within the schema. So this allows us to, even something that we've created in OR, we've worked with the database, being able to store those objects within the database, and our production code that may be using SQL to be able to call these particular items doesn't need to get modified or changed or updated in what we need to do. So a couple of other things is before we get going is we can also kind of start creating functions. So a kind of an OR function, it consists of here is a series of commands that we can actually group together and run as one particular object. So in this particular case, what we want to do is we want to kind of create a function that's going to take our mining data, build view data. We want to kind of map that into the MDBV object, and then we want to do some aggregation on it, and then we want to plot it and then display the results. So we can take that particular function, define that particular function, and we can run that within the database. So it's taking that function, sending it off to the database through the transparency layer. It's working out what bits can I actually use in SQL, what bits can I actually use in OR, and applying it, producing the results. And we get to see here this hasn't displayed very well. We get to see the graph that has come out. We get the results coming back, the aggregation of it, and we get the graph coming out. It's just not being displayed well here because of the resolution on what we have. And that's effectively using ORE, right, in our OR environment. Next step, though, is we can flip over to using OR within SQL. But before we do that, I just want to show you a couple of other things, or one other thing, which is to do with using the parallel option. So we can set various features, database features for our session. So within our parallel environment, within our multi kind of processor environment, we can say, well, we don't want to use the one CPU option. What we can do is we can turn on the parallel option. We can say, well, we're going to take the default setting that's there in our database. Right, in this particular case, well, we can set it on as true, but we can also say define the degree of parallel that we want to be able to use. So it's there, it's really efficient, and allows us to maximize the performance of accessing the data, analyzing our data using the in-database features. So now I'm going to switch back over to SQL. So we're back in SQL Plus. And what I want to show you here is how we can actually take some of the OR scripts and OR functionality and embed it within SQL and PLSQL. The example I'm going to show you now is being able to take a generalized linear model, right, and being able to define a function, an OR script, that will create that script, that will define the function, that will go along and generate a GLM model based on the data that we have, on the target value and the data that we have here from our table, and being able to store that in our data store. So what it tells us is it's going to generate the model and store it within an OR data store within the database called a data store name. So we have a number of ways of being able to run this. So the first thing that we need to do is we need to be able to run that script within our schema. So being able to run it against the data, we can take those attributes that we're passing as variables from our table. It will generate the GML model and then store it in our data store within the database. So this will actually will create the Oracle will create a data mining model using OR in an OR data store in our schema. The next step that we can do is we can start looking at how we can actually use that GLM model within our data. There's two ways to do it. The first one is we can do it in batch mode. So with batch mode, we want to be able to say at the end of a day or as part of a kind of a batch processing run, we can add this particular functionality in. So again, we can create or define a particular script that will load data from our store. We'll take the data mining model that we want to do it and apply the data to it and being able to kind of present the results back to us. So that's the script that's effectively writing lots of OR code or a few lines of OR code that's going to run this within our database. So when we come along and run that, we end up getting our data. Alright, so we're going to run it, taking data from our apply data set, just like what we used back in our studio, and being able to pass in those values, pass in those the model from our data store, and being able to display the results from it. So here what we get is a sample of the data that from that table, but we also get this predicted value. So this is the predicted score that the generalized linear model has produced for our particular data. So that's doing it in batch mode. Sometimes what we want to do is we want to be able to do it in real-time mode, or another way of looking on it is can we do some what-if analysis on our data. So we can still take the same data mining model, and in this particular case, rather than actually passing in data from a table or from a view, we can actually pass in the actual values that we want to be used as part of the model scoring exercise. So when we pass those values in, we get out the predicted score of what we were trying to particularly target. So this way what we can do is say if we're in kind of a real-time mode, say if we're gathering customer data as it's being entered, we can actually do real-time scoring as each new value is put in. We can do the prediction, or if we change certain values, does that change the predicted value on it? So we can do lots of integrated real-time scoring on it using the OR code within our database, being able to use all the OR libraries within the database, being able to apply it to the data in our database. When we're finished doing that, we can do other things. So remember in our previous example in OR, we were able to do some aggregation of the data, and then do the plotting of the data. Right? We can build that within a script within our code, and when we run that particular SQL script, we get a plot. We want to create a graph. Now, within SQL, we can't actually view the graph, right? So what we end up by getting is a graphics object defined within the database, or an image graphics object defined within the database. And we can use this object within some of our Oracle tools. We can take that image that's stored in the database, or that's created within the database, and we can actually store it and use it within some of our products. For example, we can take that particular image and we can include it within our OBIE, or in any of our other kind of type of applications that can handle a PNG type format. So this allows us to utilize the graphing capability within the Oracle database and within the OR packages and libraries that we can have, and we can get greater insights and use these to help us to understand our data in a lot more detail. So if we kind of take that particular script that I just showed you in SQL, we have the image that's created, and here's how that image has been actually included within an OBIE dashboard. Right, so it's really easy to do, really simple to do, increases the graphing capabilities and the ability to analyze and process our data in a lot more detail. At the end of the day, data mining, data science, predictive analytics, whatever you want to call it at the moment, within Oracle is really just SQL. So we can do lots of statistics, lots of data mining, lots of predictive analytics. But whatever we can't do within SQL, we can use or Oracle or Enterprise to be able to incorporate all the different features within, or all the different packages to provide us with greater flexibility. If we go back to the challenges that I outlined at the beginning about the challenges facing OR and being able to use OR in a more kind of production type environment, now with using ORE, we can overcome all of these different difficulties. We can scale with the data. We can utilize all the performance benefits that exist within the database. And now we can actually include it within our production environments, within our not just our dashboards, but within our front-end applications, our batch processing, by including ORE, being able to include all the packages and scripts within it, and then also being able to run it within SQL. All of these applications already can interface into SQL and being able to use those. So by using the ORE, the embedded database option, we can actually being able to overcome all of these limitations, say, of the base OR tool, and being able to get greater insights. What happens when a new package or a new function or a new graphing or a new algorithm or new statistical techniques becomes available is, well, it's very simple. All we need to do is be able to install that on the database server as part of the ORE install. It then becomes part of the database server. So this can save us a huge amount of time, so we don't have to wait for the next release of the database, whether that's in 18 months, 2 years, or whatever it might be, is that we can utilize those packages as soon as they become available, as long as they're compatible with the current version of ORE. So that kind of brings me to the end of the presentation. So thanks very much. Just a quick reminder of the book on Oracle data mining and some elements of OR and that. If you need to contact me, the easiest way is if you just kind of Google me, kind of Brendan Tierney Data Mining or Brendan Tierney Analytics, you'll find me. If you just put in Brendan Tierney, you'll find some cage fighter. So that's obviously not me. So make sure you put in the extra bit of details. I'm not here to take questions, so perhaps if you want to email me your questions, what I can do is I can put together a blog post with all the different questions and my responses to them, or maybe kind of some of the members of the committee can maybe kind of gather up the questions from the users, and if you send them on to me, I'll respond to them over the next few days once I be able to get kind of email and back onto the internet once I'm off the boat. Alternatively, if you don't want to email me with the questions, you can always look me up on Twitter. So it's Brendan Tierney on Twitter, and you can send me your questions there. And again, likely I'll respond on Twitter or kind of amalgamate them all into a blog post. So that's it for now. So thank you very much for listening to my presentation, and someday I hope to get to do it live at this kind of sake. Bye.